Hi, everybody. Welcome back, Azure Cosmos DB Live TV. I'm Mark Brown, and I've got with me this week Abinav. How are you, sir?
Good, good. How are you?
Good. I'm doing great. Episode 46. We're going to talk about some of our HA features today, specifically around failovers. And Yeah, so some stuff we'll talk about how failover works. I think you're going to cover today, and then I think you're going to talk about some upcoming stuff as well, right?
Yep. Couple of things
Great.
that are in the works there as well. Yep.
This is good. I like breaking news on this show, at least when it's intentional. Sometimes, sometimes not so intentional. So yeah, right on. So yeah, let's talk. What have you got? What are you going to show us this week?
Cool. So a few things that I wanted to talk about. We specifically in the failover family of things. So we've got a couple of failover options, and then we've got a couple more that are coming, and each one has its own set of benefits that it's meant to provide our end users, particularly from a high availability standpoint. So I'll cover about four of them, and then we'll do a little bit of a compare and contrast type of thing to just walk through what are all the differences, when do they really apply, when does one help over another, when does one not help over another, just to give folks just a lot of visibility into what's really happening under the covers when we talk about all of these failover options.
Yeah, cool.
Yeah, and so this first one here actually, so this is one of the most vital things. We've had something for a long time that we've called automatic failover, and we're now rebranding this to be called service managed failover. And the idea there is that when you think about an automatic failover, the idea is you've got an active passive Cosmos DB account, so you've got a dedicated write region, the primary region. You've got one or more secondary read regions that are purely only serving read traffic. They can't actually take in writes. But what happens though is that if there's a partial outage, or if there were to be a full-blown region-wide outage in your primary write region, you can opt in to have what used to be called an automatic failover. And the idea is that the service detects that there's an outage, partial outage, full outage, whatever the case may be, triggers a failover under the covers automatically into one of the read regions that you've specified. And there's a hierarchy there, right?
Mm-hmm.
What's confusing about that, though, is that has made it seem like this is instant, in that the moment any glitch is detected, the service automatically just shifts to make the next region in line the writable region.
Yeah.
When in reality, there's a lot of subjectivity associated with it. Right? Typically, I don't know if we've ever seen a full-blown regional outage. It's always like a cluster.
I have. I don't know about customers, but yeah. But the answer to your question, yes. So
yeah. And so what we've seen more recently, at least, has been something like a single cluster that goes down. And what that means is, there are accounts that are going to be pretty severely impacted. There are some that will barely be impacted, depending on how widespread they are, how scaled out they are, and things of that nature. But the idea there is that doing a failover in itself is expensive for the user. And what we mean by that is, if we react very aggressively to the smallest of blips and we started to trigger a failover, now all of a sudden the customer could be impacted pretty significantly from a latency standpoint, right? Like, you've got your application server in region 1. Region 1 had an issue for 5 seconds. We reacted to it, we did a failover, and then all of a sudden your application server that's in region 1 is now going cross-region because we triggered a failover too quickly.
But let's break that down a little bit, because there's a few things happening here. And for something that happens for 5 seconds, you're going to be suffering a lot longer during that failover, right? Because some things have to happen here before we can do it. We've got to, one, drain the replication queue, right? If we can still contact the region, right? Or if the regions can still be contacted via over the network. And then that has to happen. So writes at some point need to be halted so that replication queue can drain into that secondary region before we can trigger the failover, right? Because our failovers are supposed to be RPO 0, right?
Yeah. So actually, interestingly, what happens is, and this is true of all of our client drivers, in that You're right. There's some checks that need to happen for the failover to actually be triggered under the covers and for the right region to be shifted. But even then, if you've got a very widespread account, and by that I mean several hundreds, maybe multiple thousands of partitions, all of them aren't transitioning at exactly the same time. So there's this concept of a streaming way in which we do it. And there what happens is the original right region will throw back an error to the client saying, I'm no longer the right region, at least for this partition. The client then reacts to that and then auto routes those writes to the next region, which has either already completed the failover process or is in the process of fully assigning all of those partitions to be writable in the secondary region. So in theory, yes, the failover is a no downtime operation and the clients are reacting to them. But while that's happening, you're still having this latency impact of the client trying to talk to the original region, then discovering that it's no longer the writable region, then retrying in the read region. And that entire process can take a while. Yeah. And that's sort of what we don't want to do in way too aggressive a manner, right? So that's one side of it. And then typically there's a good amount of subjectivity in that we also want to make sure that all of our automated processes that exist from a mitigation standpoint. So if we had something that went down unexpectedly, something that became unavailable for an intermittent period of time, how large is that impact? Assessing that impact, ensuring that all of the automated mitigations that would normally be triggered at this point are not going to work. All of those checks need to happen before we can actually trigger it. And then every now and then, it's not always going to be automatic. There is an element of a human touch that would require somebody to come in and say, okay, at this point, there's really nothing more that can be done. Let's go ahead and hit that button that triggers a failover for everybody.
And interesting you said in there as well as that the individual partitions fail over independently of each other, right?
Yeah. Yeah.
So I understand that, but it's something that maybe users don't maybe typically understand is, we're a scale out database, right? So we go like this, and each of those partitions is independent of each other. They don't even really necessarily know about each other. So when we do a failover, it's not like failing over a single thing. It's lots of little things. And of course, like you said, the more partitions you've got, the more involved this entire operation is. You're flipping basically all of those hundreds or thousands of partitions to new endpoints. So
exactly.
Anyway,
yeah. And actually, it's interesting you bring that up as well. In that it's the other question that we get around that is it data dependent? In that if I had 1 terabyte versus having 5 terabytes or 10 terabytes, is 10 terabytes worth of a failover going to take me much, much longer than 1 terabyte worth of a failover for the entire account? So it's not actually dependent on that. It's purely dependent on the number of partitions that your account has. I mean, what we do know, obviously, is 1,000 partition account would take longer to failover than a 10 partition account or a 100 partition account. But it's also not like a 45-degree angle where a 1,000 partition account will take 10 times as long as a 100 partition account.
We don't serialize the failover. We're doing them in parallel, but still, the more you have, it's the more longer it's going to take.
Yep, exactly. So, I mean, for anybody that's looking at any of our docs, any mention of automatic has now been called service managed. We do have some portal changes that are coming in as well. So today, when you go into that replicate data globally tab, you have a way of saying, add region, remove region, and you click on the map. But then you've also got something that says enable automatic failover, where you're opting in to allowing the service whenever possible and wherever applicable, actually, to trigger that failover for you. That's going to soon be called enable service managed failover, just to provide clarity. I will say this doesn't impact any of our RPOs or RTOs, so all of that remains the same, but we just wanted to clarify that confusion of, the moment something goes wrong, this is instantly going to change, and that's not the case. There's a lot more to it.
Got it. So you got portal changes. People are going to see that coming soon. But we talked about this also. If for people that are using, say, ARM or Bicep, if they're talking directly to our resource provider, that's not going to change right away, correct? That's going to take some time,
That's correct. Yeah, yeah, and that in itself has could possibly add more confusion because that's going to continue to be called automatic failover, but changing it is potentially also going to be challenging from a customer standpoint, and that now that's in theory a breaking change, and anybody who's already set up all of these from a CI/CD standpoint would have to go in and make all of those changes again, and so we really need to figure out what the best approach is there. So for now, those are going to stay the same, and then hopefully we'll have a plan.
Yeah, our friends over in the ARM team and Azure One SDK team provide a good level of friction to changing interfaces for anybody's resource provider. So that'll take some time, and we'll have to have both of those surfaced within there, and then kind of have them bidirectionally work. Back and forth. So yeah.
Exactly.
All right. Well, cool. I think definitely the name is, I think, is a better moniker for that operation and what it does than automatic. I agree. I could see how customers could be confused.
Yeah.
Cool.
Okay. So the next thing that we're looking at here is this is sort of an extension to the concept of a service managed failover that we're going to be calling a forced failover. And this too will go through its set of steps where we'll have portal visibility and all of that. But the idea here is that when you think of what's happening in a service managed failover, you're essentially saying, I, the user, am putting the availability of my account at the mercy of Cosmos DB. So when Cosmos DB as a service determines that there's enough of an impact, whether that's a cluster-wide impact, a region-wide impact, when Cosmos DB has deemed that automated mitigations are no longer going to work, Cosmos will then trigger that failover. We may not want to wait on that. So you may not want to have your application, which could be a tier 0, mission critical, every second there's revenue loss, and you want to be able to do this as quickly as possible. So what we're actually adding effectively is a red button, and this isn't there yet. This is something that's coming. We don't have an ETA, but we should have an ETA for this soon. An ETA for an ETA should be out pretty soon. But the idea is that the user now takes full control of what's happening. Okay. And effectively, the user is saying, I don't care what the service is trying to figure out. I know my account is being impacted. So whether or not everybody in this region or everybody in this cluster is going to be failed over, I'm not going to wait on that. I'm going to do it myself, right? And everything beyond that is exactly what would happen under the covers. So this could be a little confusing in that we've already got something called a manual failover, right?
Yeah.
Where you can already do this yourself. So what is the difference between a manual failover and a forced failover? So you touched on this a little bit earlier, Mark. So in a manual failover, what we're saying is nothing is actually wrong. So everything is up, everything is running, your write region is available, your read region is available, everything is there, but your traffic patterns may have changed over time. So it may have seemed like once upon a time, East US is where all of your write traffic was needed. That's where your application server was deployed. And that was the region that was serving all of your writes. Over time, traffic patterns changed, your application's requirements changed. And maybe West US is now where most of your write traffic is coming in. So instead of having your application servers in West US constantly do a cross region called East US, you're saying, I'm just going to change my write region from East to West and have all of my writes served locally, because that's the direction in which things are going for me. So at that point, you're simply changing the pattern, not necessarily because anything has gone wrong. It's just because that's just how you want it to be done right now. As an extension of that, we've had some customers use the follow the sun model. So during the daytime, you've got writes originating in East Asia. Later in the day, as the sun starts setting there, you've got writes originating in East Europe, maybe then West Europe, and then eventually it makes its way into the Americas. So you could actually do a failover every 8 hours, and you could do this multiple times a day. But that's a manual failover where nothing has gone wrong. And what happens under the covers when you do that is that's where we do something called a gracefulness check, where we're actually saying, when you shift from region 1 to region 2, we want to make sure every single partition in the region that you are now promoting to be the new write region has actually caught up to all of the changes that were made in the original write region. So every now and then you could have a scenario where one partition is lagging behind for whatever reason by a few seconds, maybe even a minute, although that's pretty extreme, but let's just assume that. So in that scenario, we're actually going to say, we need every single partition to have caught up to that smallest of windows before we can fail over the entire account to the next region. So even one partition that is lagging behind is going to stop the entire thing or delay the entire thing, right? And so the idea there is that, again, because while the failover is happening, your client knows which ones are done, which ones are not done. It's not a downtime situation. This is what's happening in a manual failover when everything is up and running. In the case of a service-managed failover, what we're saying is, at this point, we actually have an outage. So there's going to be a bunch of partitions that are unreachable. So we're not going to be able to do this gracefulness check. We don't have the luxury of saying, let's wait for this partition to have fully caught up to what's happening in the original write region, because at this point, the original write region is unreachable. Yeah. And we want to be able to restore availability as quickly as possible. So we skip that check and we say, forget about that. We want to favor availability over consistency. So there is a caveat there in that you can have data loss, right? And there's going to be a warning sign here when you actually trigger a forced failover that actually says, hey, are you sure you want to do this? Because effectively what's happening is you're marking your current write region offline. And that's what we're seeing here. So it's a little dimly lit, but effectively what happens is if you're triggering a forced failover from West US to one of your other regions, West US becomes, it's essentially being marked offline, and we're promoting one of the other regions as the new write region. So skip the gracefulness check, hit the red button. Something has clearly gone wrong. You're seeing diminished availability, significant impact on your write region. It may not even be clear if it's a Cosmos issue or a networking issue, but at that point, even from a user's perspective, you just don't have the luxury of time. So you're saying, forget about all of that. I'll figure out what's going on. Something is clearly happening, and a service managed failover has not yet kicked in. I'm just going to do it myself because it's now been 2 minutes of issues, and I cannot risk any more of a downtime. Right?
So this makes sense. Let's say someone does a force failover and they mark the region offline. Explain kind of the process or what happens, say, after a region is recovered.
Yeah, good question. So if we go back to the same thing, you've got West US as your current primary. Something is going on. You have no idea what it is. You're saying, forget about it. I hit the red button and I trigger a forced failover. Mm-hmm. We fail over to East Asia, just as an example. When West US does come back, it's now brought back as a read region. So the first thing that we actually do before bringing the region back online is we are actually saying we need to ensure that this region has, in fact, at this point, fully caught up to all of the changes that were made in East Asia and East US while West US was down, right? So that is one check that we make to essentially say we will only allow this region to even be brought back or marked online again after it is fully caught up. It's effectively, you can think of it as the same as what would happen if you just added a new region. So when you add a new region, it's not just available immediately. We're saying this new region needs to get all of the data from the existing regions. And then when it's at that tipping point where it's right there, that's when it becomes online. Same thing here, right? So it needs to catch up. When it's brought back online, though, it's not shifted again to be your write region. And the reason we do that is because at this point, the application may have made a bunch of changes. So your app server that was initially assigned to trigger writes in West US, that may have now been moved to East Asia. And so if when West US comes back up, promote it back to the write region, again, you're going to have a latency impact. And we don't want to do that. So we want to put that control back into the user's hands.
Right. So they'll do a manual failover back to West US when they're ready.
Exactly.
On their side. What happens to data that is committed into that West US region, but does not replicate. Can we talk about that for a moment?
Yes, yes. So that is something that goes into what we call a conflict feed. And you can retrieve a conflict feed in very much the same way that you would retrieve an indexing policy, you would retrieve compound indexes, essentially anything associated with the container object, right? Whether you're doing this, you'd be doing this programmatically typically. But the idea there is that you wrote a bunch of data to WestUS. 99.9999 something, however many nines of a percentage did actually make it to the other regions. That really tiny bit that could not make it, just as WestUS went down, is now made available, but it's only made available once WestUS actually comes back up, because that data is only there. So as soon as WestUS is brought back online, you will see this conflict feed get populated with essentially all of the data that did not get replicated to the other regions. And here, we're now again putting this back on the user to say, you would want to retrieve this data, you would want to check if newer updates since that time have already been pushed to your new write region. And if that's the case, then you're going to want to resolve this yourself, because we don't want to now update that and update newer data with stale data,
right?
Just because we want that replication to kick in.
And we have code that shows how to read from our conflict feed. I believe it's in the multi-region writes or the conflict feed section in our global distribution docs, in our docs there. So yeah, so if customers want to take a look at that, they can go. It's not possible to really test, I guess, conflicts. Well, you can. I mean, I have a demo I built where I enabled multi-region writes and then attempted to generate conflicts by simultaneously writing into multiple regions at the same time. And you kind of have to almost time it, if you will. Like I would write in the order I would issue the writes would be from the furthest region first and then the closest region last, to try and use more or less the speed of the WAN or the speed of light to try and trick it, so I could commit into different regions before they could kind of resolve or get committed on the master or in the primary region there. So it is possible to test reading from the conflict feed, but you got to kind of trick it to do that. So
yeah, and even within the conflict space, there's two components there. There's one is the logical side of things that you were talking about, where in a multi-region scenario, the application has actually triggered writes rather the same write to multiple regions and caused a conflict where before each region could replicate to the other region realizes, hey, I already have this, and how do we resolve that? And then there's the actual service, not service triggered, but service caused conflict, which is in this scenario where in an active passive setup, the active region was unable to replicate to the passive regions or the read regions. And because of that, it led to a conflict when a failover happened. And then that's the other side of it in an active passive setup, where something like that really comes into play with these kinds of failovers. So yeah, I mean, ultimately it's on the user to figure out what should and should not be updated after that. But we do make that available as soon as the region comes back up. And then, you can decide.
Yep.
I will say this is primarily a core API feature, at least on the conflict feed or the conflict feed data. That's something that we're looking at to add for other APIs as well. We're not there yet, but that is our plan. But as of right now, this is very specifically for the core API.
Yep. Question from viewer here. In case of manual failover and nothing wrong with WestUS, will the region become a read region right away? Well, the answer is yes. If you're doing a manual failover, right?
Yep.
We're not going to drop the region. It's only the forced failover that actually drops the region entirely.
Exactly.
Account, right. So
exactly. Yep. So that becomes a read region right away, and then everything is pretty much smooth from that point.
Yep. Okay.
Okay, cool. So I'm going to switch screens here a little bit and just do a bit of a comparison. So, we're going to have multiple of these, and then I'll talk about a new feature altogether as well. It's probably going to require even more detail. But the idea here is So we've had these two kinds of failovers for the longest time. One is now being rebranded. We're going to introduce this new red button called a forced failover. How do they all compare against one another? So, and that's sort of what we're going through here. So at the root of it, if we think about who can actually trigger either one of these, right? So manual failover, obviously that's completely user triggered, no issues, no outage, no downtime, nothing that's actually impacting the user outside of traffic patterns changing. So this is completely user triggered. Service managed failover. This is subjective, so this is done entirely by the service. This is CosmosDB under the covers, reacting to outages, whether those are partial cluster outages, full cluster outages, full-blown regional outages. And so at this point, everything is triggered by the service, either by somebody at a very specific point that says, okay, things didn't work, I'm going to click the button for everybody to move, or there are parts of it that are in fact automatically done as a reaction to things that we would know, right? So this is entirely done by the service. The forced failover, that's the new one. Now, this is where you're doing it yourself, again, because something has gone wrong. You don't want to wait on the service to go through its full set of checks and balances before doing a failover. Very, very critical service. And you're saying, I'm going to do this myself, right? So that's completely done by you. Exactly the opposite on the triggered by the service side of things. It's probably redundant. So anything that was user triggered is not triggered by the service. Obviously, anything that cannot be triggered by the user is triggered by the service, right? So here, the only one that's triggered by the service is the service managed failover. So hopefully the naming in itself makes that very clear as well. The next one is actually interesting. So triggered during a regional outage. Now, in the case of a manual failover, you won't even be able to do that in the event of an actual regional outage. And the reason we're saying that is because, as we discussed maybe 10 minutes earlier, when you have a manual failover, what we're saying is we need to be able to verify as a service that the region to which you're now failing over to has fully caught up. And we also spoke about, as you brought up, Mark, this is a partition by partition thing. So every single partition in the new region that you're trying to promote as the primary region has fully caught up to changes that were made in the current primary region. So that check has to happen. And in the event of a regional outage, we're not even able to do that check, right? And the idea here is the manual failover has to favor data consistency. There cannot be data loss. And so you won't even be able to do this in the event of a regional outage. Now, the other two, the service managed failover and the forced failover, are very specifically for something that would happen in a regional outage. And there's a bit of a subtle difference there as well, and I'll get into that in a second. But in the case of a service managed failover, that's exactly what it was designed for. We go through our list of checks and we deem a particular region to be down. We know the list of accounts that have been affected. And I say list of accounts that have been affected because it may not be every region, every account in that region, if it's a single cluster or a couple of clusters that have gone down. If every cluster in the region goes down, obviously every account that had presence there would have to be failed over. But that, I honestly can't remember the last time it happened.
I don't think I've ever heard of that.
Yeah.
Where every cluster, it's not us that goes down, it's something else, right?
Yeah.
It's like usually, I'm not going to point fingers, but
yeah. I mean, over 4 or 5 years, I think it's only ever been the odd few times when it's happened. It's been a single cluster, and even in those scenarios, it hasn't been the entire cluster. It's been a majority of a cluster, and so any account that's in there is now going to be failed over, right? But here, what we're saying is we're very specifically talking about a region from the perspective of Cosmos DB. So we know for a fact that Cosmos as a service has had a dip in availability in that region. Now, the thing about a forced failover is that may not always be clear. So all that you see as a user, because this is triggered by the user, is something has gone wrong, right? I know I'm experiencing some availability loss in this region. What you may not know for sure, though, is it a networking thing that's impacting my client, so my VMs, my application servers in that region? from talking to Cosmos DB in the region, or is it truly a Cosmos DB problem? But you also don't have the luxury of time. At this point, you're saying, I don't care, it doesn't matter. Something is going on. Let me just mark this region offline and promote another region as my primary. And then once things come back up and all of that, I can do my RCAs later. But for now, I just need to do this. So you're not waiting on a service managed failover to, first of all, even deem whether it is in fact an issue in the region. You're simply saying, I'm going to hit the red button and I'm going to move. So this may or may not be triggered during a regional outage, but at least from the user standpoint, it seems like a regional outage of some kind. And so that's where a forced failover comes in, right?
Yep.
And this was to answer, again, the same question that just came up, is what happens to the original region and is that marked offline? So in the event of a manual failover, I should probably change that to no. But the reason it's not even applicable is because that's not even the purpose here. All that we're doing is we're saying shift traffic to another region, but by all means, keep this region up and running. So manual failover doesn't do that. Service managed failover actually does do this in that your original region is in fact marked offline, and the behavior here is exactly the same as what would happen in a forced failover. So one thing to note here is because we're favoring availability over consistency, you can actually have some missing data, and that data will be made available to you later as unreplicated data through the conflict feed. But your original primary region that was in fact the right region that is potentially experiencing some kind of availability issues or networking issues when talking to that region, at this point, we are marking that region offline. So that is what's happening.
Yep.
And of course, we covered this, but when it comes back, it's brought back as a read region, and then it's on the user to bring it back online, right? So that's what we're talking about here. So again, in the case of a manual failover, there's no concept of the original region coming back online because it's always been online, so no issues there. Service managed failover, yes, when it comes back online, it's brought back online as a read region. Same with the forced failover also. We spoke a little bit about the conflict feed, and obviously this is again something that only applies to the service managed and forced failovers because effectively they're the same thing. One is triggered by the service and one is triggered by the user before the service can actually get to it. And in these scenarios, there's a very good chance you may see nothing in the conflict feed. And at this point, what it actually means is even before you could write data to the region that went down, it did go down. So you probably had connectivity issues going there anyways. And so everything that needed to make its way to your other regions did, in which case, even when this region comes back online, you're not going to see anything populated in the conflict feed. Rare scenarios, you could have outliers where data didn't make it. At that point, it gets pushed. And again, that's only available for service managed and forced because we're just reacting to availability loss and not favoring consistency at that point. This is actually interesting. So the next one is what we were talking about when we were discussing the whole concept of graceful versus ungraceful, right? Mm-hmm. So manual, this is favoring consistency over availability because the idea is that, I shouldn't say it's favoring one over the other, it's favoring consistency. That's it. Because there is no issue with availability. Mm-hmm. So we have to make sure that the secondary region has fully caught up. And so every now and then you may see, a manual failover taking a little longer than it needs to, going through retries. So we do have metrics that we publish to log analytics, and I can show what that looks like as well. But it'll essentially tell you when a failover started, when a failover completed. Sometimes you may see multiple of those showing up because they had to be retried. Usually what's happening in that scenario is there's one partition or a few partitions that for whatever reason are lagging behind. And we're waiting on those to actually drain that replication queue before we can promote that particular partition in that region to be writable. We have the luxury of being able to do this because everything is up. Service managed, we cannot do that. So we're saying, forget that. I'm not even going to think about this. Just failover and restore availability as quickly as possible. Forced failover is a little interesting in that what's happening here is because it's user triggered, what we're saying is if one of our clusters went down and let's say 20% of this account's partitions were there, right? For the 80% where we are in fact able to do that gracefulness check, we will. So there we're saying we actually will do that gracefulness check if we are able to contact the partition in the current primary. For the other 20% where there is an outage, there we're not going to contact the original partition because it's unreachable, and those we will skip. So it's kind of like a hybrid. Wherever possible, we will, and when we're not able to, we won't. So that's one separating factor.
What is the order of things? So I know at some point the service will tell the SDK, okay, I'm not accepting writes, right? And SDK, I think, will hold those, if I'm not mistaken, and queue them up until it can reach a new writable region, right? There's an order of things that happen here, right? Where I know SDK will stop accepting writes, and then there's a period there where it'll keep them. And then whether or not that failover works or not, because I know you're saying there's like an interval in here where it does these retries or whatever stuff. But I think at some point, if it can't drain it, it'll say, "Hey, I'm sorry, I can't do this failover right now."
Yeah. So there's actually a few different layers to that as well. So there's, just like we do in the SDK where we've got a request timeout, we've got a maximum time spent retrying on failures. So you would see that with throttle requests, but you would also see that with things like service unavailables. So what the SDK is actually doing is it's saying, I will initially reach out to the current primary. And if that primary it has already been shifted to another region, then that guy will throw a particular status code. Typically, that'll show up as a forbidden exception because it's saying, hey, you're actually not allowed to write to me in this region. So there, the SDK will react to that and then simply retry that request in the next region, right? At this point, we're assuming that the failover, at least for this partition, is either in progress or has already completed. If for whatever reason that other region is also not available, the SDK will retry for a certain amount of times, and this is configurable, but then it'll bubble that failure back up to the caller, either in the form of I think at that point it would be a service unavailable exception, right? So at this point, the application can retry that, and then hopefully by this point, whatever needed to happen has happened, and it goes through. The other side of it, though, is that when the failover itself is taking a lot longer. So and let's talk about what happens in a manual scenario, right? So what we're saying is here, there's nothing that's unavailable. It's just taking longer. When it's taking longer, you're still able to write to the original write region. And it's only when that guy has completed that, and by that guy, I mean that partition has completed that switch, that this guy then says, any additional writes that come in, I'm going to throw a forbidden exception. And then the SDK catches that and then goes somewhere else. If for whatever reason that times out, your original guy is still there to continue accepting writes, right? So that's what happens in a manual scenario. In the other two, at this point, we're saying the original guy is actually down. So original guy is not even reachable. We have triggered a failover, or the user has forced that failover. Until that actually completes, you're not able to write there at all. So you will have availability loss on writes while that is still happening. So those, I will say, usually are much faster because we're skipping all of the gracefulness checks. We're not waiting for anything. So usually that whole thing of taking longer is usually only in the manual failover scenario. The other ones are quicker.
Yep. Okay.
Cool. This has been a common question, actually. So where is it available and where is it not? So we spoke about the conflict feed being available only for the core APIs. But as far as the failovers themselves, whether it's a manual, whether it's service managed, the soon to be made available forced failover scenario, that will be applicable for any account. So every single account, regardless of API, whether it's the core API or any of our open source APIs, they will be able to they already have the first two, but they will have the third one as well once it becomes available. The multi-region write accounts, this is actually interesting. So when we talk about a failover, regardless of the type, what we're really saying is we're switching the write region, or rather we're making one of our secondary or read-only regions to be the new write region. So if we're talking about a multi-region write account, it doesn't really apply in that you don't really need to do a failover because every region is writable. All that you're saying is my application servers in region 1 that we're writing to region 1 will no longer do that, and I can simply make my application servers in region 2 write to region 2, because region 2 is already writable just by virtue of this account being a multi-region writer or an active account, right? So it doesn't really apply there, at least as far as a manual failover is concerned. Service managed is a little interesting in that while it's technically, actually, it's not interesting. I take that back. We're not doing a failover here either. So there's nothing to failover. What happens is the client is trying to write to that region. It sees the same exception, not a forbidden, but it'll get a service unavailable exception. And then the client, just like it retries on reads to a remote region, will actually do that for writes. It'll say, okay, I couldn't talk to your preferred region. I'm going to go to the next region in line and issue writes there. Forced failover is actually where it gets interesting. So here it is in fact applicable. And the reason it's applicable is because you are now marking that region offline. So slightly weird use case in that it's technically doable, although you may not see much of an advantage here. But if you wanted to mark a region offline, even in a multi-region write account, you could, although I would say from a design perspective, from an architecture perspective, you're better off simply saying, whatever application servers we're writing to that region, let me stop that guy. And from an application standpoint, just divert traffic to my app servers in the other regions so that they can write locally. And then at some point when this guy's available again, I do some load balancing of traffic across my regions.
Doesn't our SDK automatically redirect to another region if it cannot reach the region? So again, why would you need to do that?
Yeah, good point. So the SDK does do that, but now there is that latency impact. So the SDK is always saying, I'm in region 1, so I'm going to try writing to region 1. And then when I get a failure, I'll still do one more retry to region 1. When that also fails, then I'll go to the next region in line.
Oh, does it continue to do that even after the region, even after it gets the first, I'm not available?
Yeah, so there are some scenarios where it'll mark a partition offline or mark a region offline for a small window, but it's not going to do that indefinitely, because the idea there is that it's assuming that whatever's happening is a temporary thing.
So you need a way to signal to the client that, hey, don't even try. Just go to the second one that you've got in the list.
Exactly. So that's the use case where you would simply say, let me just stop everything going to my app servers in this region, because I don't want them to do those 2 attempts and then go across DC. I'll just do everything in my other regions for a while.
Okay.
And that's essentially it, as far as looking at what the differences are. I am going to jump into what's coming, which is yet another kind of a failover, which is interesting. So, just to recap very quickly, we've got the manual where nothing is wrong. We've got service managed where something is wrong in a region and we fail over entirely. We've got the forced failover where the user takes matters into his or her own hands and then triggers that failover themselves. But it's for the entire region. What we're now saying is, can we be a little better? So can we actually do this on a partition level as opposed to for every partition in the region? And what I mean by that is, let's assume a scenario where you've got 100 partitions for your account in each region, and 20 of your partitions in your current write region happen to be on one of our clusters that is having some sort of issue. What we would normally do there is we would fail over all 100, not just those 20, to the next region in line. And so today, your only options to avoid something like a data loss or to minimize RPO and RTO is, on the one hand, you've got a single master account where just one region is writable, and you pick strong consistency. So unless a quorum number of regions have accepted your write, it doesn't even become available, right? So you don't have to worry about a conflict feed and all of that. The other extreme is where you've got this active scenario where every region is writable. And so your RPO in itself may not be 0 because one of your regions did go down at some point, but your RTO is 0 because you're simply retrying your writes on the next region. But we wanted to come up with something that was down the middle. So only for the partitions that are actually impacted, we will do a failover. And it's going to be very similar to a service managed failover or an automatic well, what used to be called automatic and what we'll now call forced, with some level of enhancement in that we're not actually marking one region offline for a while and waiting on it to come back, and all of that complexity goes away. So if we go back to the scenario with 100 partitions, with just 20 of them being unavailable for a certain period of time, 80% of your partitions will continue to be writable in region 1. 20% of your partitions that are on the impacted cluster will now get promoted in one of your secondaries, as specified by the failover policy, to become writable in that region. So you have this mix. Wherever possible, you're writing to your preferred region. Wherever it's not possible, just for that subset, you're writing in one of your other regions. And the SDK is doing exactly the same thing. The SDK is saying, is this partition writable here? Great. If it's not, it's reacting to the same error code that it would get when a region goes down or when a failover has completed. And it'll simply retry that request in the other region, right? So there's a latency impact, but the idea there is that you don't have to hit that red button. You don't have to wait on a service managed failover. And it's not necessarily going to be an instantaneous thing like you would get with an active account, but the goal there is for it to be a lot faster than what you would get with a service managed failover, which can take more time.
And it seems like I mean, again, as a scale out database, this makes total sense that we can do this, right? We should take advantage of the fact that we could do this. And what's good about this is that it kind of limits the blast radius for potential impact for these types of things, right? It's only going to be some subset of data that's going to be impacted with this failover and the subsequent latency they're going to see with those writes.
Exactly. And the blast radius is also one of the more important things, because the blast radius is what sort of kept us from being more aggressive in a service managed failover, because we're saying, because we're doing the entire region, we don't want to overreact to one partition or two partitions or one node or a couple of nodes or something like that having an issue. And that's why we want to wait on all of our mitigations to do their thing before we internally hit the red button on everyone's behalf. But opting into something like this allows us to do that, because it's literally on a per partition level where we're doing the failover. So what we're saying is, we don't have to wait for the entire region to go down or for us to trigger a failover for the entire region. We're doing this just for a subset of those partitions. Now, there is always going to be the scenario where, something like this would help the more scaled out you are. But if you have a tiny account with just a few partitions or a few tens of partitions, or maybe even a couple of 100 partitions across all of your containers, if they all happen to be impacted, then, something like a service managed failover or a forced failover ultimately will lead to the same result, because everything is in fact moving, because everything was impacted. But even there, having a per partition failover will allow us to react to this a little faster than doing a full-blown failover, even though it's effectively a full-blown failover. And then even when things come back, you now don't have to do this thing of, the region was brought back on as a read region, so then I need to decide whether I want to promote this guy back to being a write region. Do I need to shift my application servers back to this region before I do that? All of that complexity goes away.
So this is only service managed, right?
Yeah.
And after the partitions or cluster or whatever is recovered, we automatically shift it back. So it's seamless, is what you're saying?
Exactly. Because we didn't want to cause this confusion of, 20% of partitions suddenly being writable somewhere and then just keeping it that way. So when availability is in fact restored, then the original write region also gets restored for those partitions to be writable again. And
So
that's
what will
managed
the
internally.
user see, or have we designed this yet? How does, so let's just say like, okay, cluster goes down. I got, I don't know, a handful of partitions that are affected. We're going to fail them over. What, as a user or an engineer or, you know, whatever, an operator, what am I going to see or know about what's happening?
Yeah. So at a high level, what you're going to see is you're going to see, for a subset of your write operations, higher latencies, because effectively what's happening is your client, the SDK, is trying to write to that subset in the original write region. Possibly it's going to retry there. And by this point, we've detected that something is wrong. So we trigger a failover. The client is going to react, or rather get that forbidden exception again, the same way that it would if it were a manual failover. And then it's going to retry that request on the other region. So you would see higher latencies. What you would also see if you had something like request diagnostics from a client-side perspective or even server-side perspective is you would see 503s piling up, 403s piling up, and then you would see a larger request volume in one of your secondary regions in addition to that. So if you actually wanted to look at, hey, why am I experiencing higher latencies? And equally, where is my traffic going? You'd be able to see that as well. I will say one other thing that is yet to be finalized is what does the downtime look like? So this isn't going to be as instant as an active account where every region is always writable. There is still a failover that needs to happen. So there is still that detection process that should be in the order of minutes, but we still don't know exactly what that's going to look like. And there will still be some availability loss, which will be a shorter duration, where your writes will actually fail. And then that's where our process is kicking in to say, okay, these guys are impacted. Let's trigger a failover. And then when that failover happens, your client that's talking to the original write region will see that forbidden exception and then start going to the other region in line. So that's effectively what the entire thing will look like.
And I'm guessing we'll throw messages into log analytics, right? So people can know what these are going on, right? And then get just, you know, set up alerts for that type of thing within there. So
yeah. And I think that in itself will go through a few different layers. So one is you've got the activity log, where that's just available as part of every Azure resource and every subscription. So there'll be some information there. What you would see, and this is still TBD, but do your control plane requests need to be enabled for log analytics to populate that data? Because ultimately what's happening is during a failover, it shows up as a control plane request. And so that telemetry will show up for those logs to say, hey, you triggered a failover at this time, and that failover completed at this time. And this was the region that was promoted to be the new write region. And all of that goes in there. We're just trying to figure out, is that the best place to also push something like this when the user didn't necessarily do it themselves, but we did it on their behalf? So would they want to know that? And then what would that look like? So that's still in the works. But of course, some level of visibility will exist in log analytics. There is a stretch goal, and this is this is going to take a while, but this is more applicable on the service managed side of things as far as visibility is concerned, which is where were we able to do a graceful failover and where were we not able to do a graceful failover. So if a region went down, but that was because one cluster went down and only 20% of my partitions were impacted, I was still able to do a gracefulness check for the other 80%. Which 80% of those partitions actually were, did we do a graceful failover for? So that's kind of like a stretch thing. We're first prioritizing just restoring availability, but then at some point as that feature evolves, we'll probably have more visibility for that as well.
cool.
Yes, and
this is great.
Yeah. Couple of things though with per-partition failover. What we're talking about here is this will go through some phases when it's made available. Interestingly, this is one of those things that will be available for our Cassandra API for a start. So core API will actually come second. It's
Wait,
not
how
going
did
to
that
be.
happen?
Yep. It's interesting. And this is also for strong consistency. So this is based on customer demand and things like that. So these will be the two scenarios where we will have the per-partition failover made available first. Once that hits stability, gets a lot more usage, then we will look at the next phase, which is opening it up to core API, the core API and all of our APIs, and then all of our consistency levels as well. So that's the
okay. So Cassandra first, but only those using strong consistency.
Yeah.
And then open it up to the rest there. Okay. Yeah, it's interesting you picked, or the team picked Cassandra API. This, to me, at least what I understand about the internals of the service, would seem to be API agnostic in some respect, because you're dealing with this at a partition storage layer.
Yep.
So it's interesting that that you're going that way. Yeah, okay. I mean, this is great, and I think customers will like this and benefit from this for sure. So, yeah.
And that is essentially it. That's all I have for today.
Well, that's cool. Yeah. Well, thanks. Got core should be first. So yeah, I know. You know what? We can rehearse and practice on the Cassandra folks first, I guess. So
yeah.
Yeah. Thank you very much, Abinav. This is great. Like I was saying on Twitter earlier, like this is one of my favorite areas. This used to be my feature area when I first joined the team on the HA stuff. So it's fascinating, and frankly, our HA features and our replication and the consistency models that we provide is really one of the core benefits and one of the coolest things about working on Cosmos as a distributed NoSQL database. We provide all that really great stuff for not free, but with very little pain on your part, right? So solving all those big problems that distributed databases in the cloud require. So yeah. Well, thank you very much for coming on this week. It's good seeing you again. Always the most awesome topics when you and I meet. I love it. Good stuff. And I can't wait to see more. And maybe, down the road, I don't know, later this summer or whatever like that, come back on and you can kind of show us what it looks like, or we can sit here and do manual failovers back and forth.
For sure. Yep.
Or what we do is we'll set up a little app with Bogus just blasting data at something, and then we'll like force failover something, and then we can take a look and see what made it, and then we can go look at the conflict feed and say, oh, there's all your data that didn't make it over. So yeah, I don't know. We'll do something chaos monkey kind of fun. That'll be good. That'll be good. So okay. So well, thanks for joining us, everyone, this week. Thank you, Abinav, for coming to us. Just a couple of brief announcements. We've got our Cosmos DB user group. We had our meetup actually just today, believe it or not. So go and check that out, aka/Cosmos DB user group, and go and check out the event in there. I've got a link to our meetup from today, pointing into YouTube, so you can go and check that out. We had a great meetup with the Azure Stream Analytics folks. That's a very cool service those guys have got, and a lot of people use it with Cosmos, and it makes sense, right? That's it's you want to do stream processing, and then a lot of people use Cosmos to save their streaming data, and it makes sense to use ASA to go and process that and do all their cool stream queries on there. So anyway, go check out that, and then this is episode 46. So we've got this and 45 other episodes you can go and check out. Go look at any of our past episodes on there. Lots of great topics, especially with Abinav. Let me just point that out again. So, and then, of course, we had our Azure Cosmos DB Conf last month. 2 months ago. It's now June. I still think it's like February or March or whatever. I don't know. But go check out. We got great episodes, great sessions from Azure Cosmos DB Conf. So go and check those out there. Next week, I've got a special guest. Will Valita is going to join us. He's out of our New Zealand sub, and he works for Microsoft. And he's going to talk about building an event streaming app with Azure Functions, Event Hubs, and Azure Cosmos DB. And that'll be episode 47 for next week. So come and join us then. And Abinav, thank you very much for coming on. It was great having you. And yeah, we'll see you again really soon.
Yeah, thank you. Thanks, Mark.
Okay. Thanks, everyone. We'll see you next week.